Welcome to another episode of PNW Weather 101, where we'll be talking about severe thunderstorm climatology. This will go over where severe thunderstorms happen most often in the Pacific Northwest, when they happen most often, and how the biggest outbreaks usually happen. Right, so let's get started with what defines a severe thunderstorm. Must have at least one of the following: wind gusts of at least 58 miles per hour, hail of at least quarter size or about an inch in diameter, or any storm with a tornado or a waterspout. If it's over land, it will either have a severe thunderstorm warning or tornado warning. If it is over the ocean or its respective estuaries, it will have a special marine warning instead. Though I will note special marine warning's wind definition starts at 40 miles per hour instead of 58 miles per hour. Doesn't matter how much lightning you have for a thunderstorm, if you don't have any one of these three criteria, it is not considered a severe thunderstorm. So how does each National Weather Service office compare in the Pacific Northwest? If you live in the Seattle area, you don't see that many per year. The median is two per year. Most of these occur in the Cascades. For Portland, the median is 8 with a tilt towards the Cascades, but not as strong as Seattle. Medford, 13. The two National Weather Service offices in the Columbia Basin, 20 in each. Boise, 33, and then 52 in Pocatello. I screw up the pronunciation. I am sorry if you live out there. The yearly record is generally in the 60s through the 80s if you are east of the Cascades plus Medford, with the exception of eastern Idaho with a 105 record in 1997. It is lower for us on the west side of the Cascades, with it being 35 for Portland and 10 for Seattle. The daily records are in the upper teens or lower 20s, with the exception of Portland at 13 and Seattle with 8. For the record, the most tornado warnings that have happened in a day is 10 anywhere in the Pacific Northwest, and that was on the same day as the 13 total warnings. For tornado warning hotspots, the big hotspot is eastern Idaho with 120 tornado warnings since 1997. Second place is Portland, which is almost double the third place, Boise. Interestingly, for Pendleton and Spokane, it's been over 10 years since both of their last tornado warnings. If we include marine warnings, and again, I'm only including marine warnings that meet the criteria for a severe thunderstorm, that really only budges the first three National Weather Service offices, aka the ones that touch the coast. In Seattle, it nudges the median up from 2 to 3 warnings a year. Portland, it nudges it from 8 to 11. Medford, it officially nudges the median from 13 to 17. However, take this with a little bit of salt, because the average only went up by about 1. But because of big year outliers, I do prefer to use the median because it better shows what our climate typically shows. The yearly record also jumps at both Seattle and Portland, with Seattle jumping to 33, mostly led by marine warnings, and in Portland it jumps by 1 to 36, with 2016 tying 2008 for that. And then daily records also have some changes as well. In terms of density, for fairness, I am only including density over land. Seattle, it's the least dense with 0.41 warnings per 100 square miles. Portland, 1.21 warnings per 100 square miles. Medford, 1.48 warnings per 100 square miles. Pendleton, 1.92 warnings per 100 square miles. Spokane's at 1.8. Boise, 1.93. And eastern Idaho, 4.95. So a significant jump up for eastern Idaho. In terms of total numbers, eastern Idaho has seen 1,539 severe thunderstorm warnings, but the area of Boise's National Weather Service office has only seen 950. That is because Boise's National Weather Service office covers more area than eastern Idaho, which is why I'm using this as a density rather than total warnings. An interesting case with Portland more than any other office is you can actually segregate it by area. When I was trying to divvy it up in terms of counties, I found there generally wasn't any favorable area that was statistically significant, with the exception of Portland and Seattle. With Portland being a little bit of a clearer picture because both the coast and the mountains have seen significant warnings. The density west of the Willamette is about 0.56 warnings per 100 square miles, while the density east of the Willamette increases to 1.71 warnings per 100 square miles. That means the density is not that much different than the National Weather Service offices in the Columbia Basin and the western Snake River Plain. So it shows that a little bit of continental influence, especially the Cascades, where in the summertime you can get a little more continental influence there to trigger a few thunderstorms on top of uplift helping with that, makes it more common there. Although we don't get the raw amount of warnings that everywhere else gets because the total area of Portland's National Weather Service office is about half of that of Pendleton terms of what the biggest outbreaks are in the Pacific Northwest. Overall, there's three kind of gold standard events that we look at. May 31st, 1997, May 28th, 2026, and May 30th of 2020. These had the most warnings overall. The May of 1997 event was also significant in the fact that it had 9 tornadoes in one day, which is the record for the Pacific Northwest. So if you're looking at west of the Cascades, the biggest event is in fifth place overall at May 4th, 2017, with 36 total warnings. Every record heard on that was west of Highway 97 that happened in the Pacific Northwest. In terms of dividing it up by month, we'll start with the Portland National Weather Service office since I know a majority of you are watching from their area responsibilities. In red is the number of tornado warnings, and the orange yellowy color is the land-based warnings, so severe thunderstorm and tornado warnings. And in blue, it's the total warnings, land and ocean. Strong peak from May to October in all facets, though for marine, you have a super strong peak in October and November. The most three common months are June, August, and October, where October gets perked up by a higher count of tornadoes, while June and August lead the way with severe thunderstorm warnings. Seattle shows a similar story, yeah, but on a weaker scale. So there is a peak in the late spring and the summer months, but it's not as strong as Portland. Marine wise, you see a lot of marine warnings in October and November, just like Portland, but there is a secondary peak during March, which I find a little interesting. For Medford, you have a stronger peak in July and August, though it is still decently strong in May and June. But once you're getting out of this time frame, it becomes hard to find any given year with a severe thunderstorm, especially once you leave April and September. For Pendleton, we no longer have to worry about marine warnings, so I have dropped them from the chart here. Pendleton has a strong peak from May through August, and April and September are very similar. If you're looking outside these months, there is only one warning that I have found since 1997, and that was in December. That does not mean you cannot see a warning in any other month. It is possible to see a severe thunderstorm any time of year. This just shows when it is most common to occur. In Spokane, very similar with a strong peak from May through August, with July being the most active month there. And similarly, April and September are like shoulder seasons. You can see some thunderstorm outbreaks. September is a little bit more common than April. And then once you get beyond that, you don't tend to see it that much. For Boise, another strong peak from May through August with very little changes. They're all within about 15% of each other. A shoulder season in April and September, and not a lot to speak of outside of those 6 months. For the three National Weather Service offices that I just mentioned, Pendleton, Spokane, and Boise, quote unquote, tornado warning season is generally the late spring months or early summer. Though again, in the case of Pendleton, Spokane, you haven't seen a tornado warning since 2016, and I believe 2010 for Spokane, though I don't have the numbers in front of me. Now we're going to go on to the severe thunderstorm hotspot of the Pacific Northwest, eastern Idaho. You do see some Rocky Mountain influence with that, which may help to beef up your severe thunderstorm warnings, though, because a lot of this happens over the flat Snake River Plain. I don't think it explains all of it. Strong peak in June, July, and August, though May is still a very strong month, and September still packs a punch. Shoulder season extends into April and October, and tornadoes are pretty consistent everywhere from April to October. If you're looking outside this month, it does become pretty sparse. So much different severe thunderstorm climatology once you're getting in, as the season is generally May through August in these continental climates, May through September for eastern Idaho, while in the western half of Oregon and Washington, especially for the Portland office, it's more from May 1st through the end of October. Now, taking a look at the biggest outbreaks and how we can tell if a severe thunderstorm outbreak is likely. Getting these upper level patterns does not guarantee a severe thunderstorm pattern. You need a lot more than that. This is just a basic overview of what can get us into those thunderstorms. All three of these had a ridge situated to the east of the Pacific Northwest. Most of the time will be coming out of a warm or a hot spell, and that gives us thunderstorm fuel. Also, we'll have some sort of upper level low pressure system situated to the south and west of us in a lot of cases, though not all, in the case of May 31st, 1997. For the biggest three events, there was also a system to the northwest that helped bring a little bit extra instability overall. The importance of these upper level low pressure systems is bringing up moisture from the subtropical and tropical Pacific, which helps fuel these thunderstorms. In terms of the flow pattern, I don't have the warning graphic for 1997 as it was county based back then, but I do have it for these other two big events. In May of 2020, most of the events was from south to north with a slight easterly tilt. On May 28, 2026, it was south to north with a westerly tilt. Started with a stronger westerly tilt with the earlier storms, and then it eventually tilted just more or towards a north-northwest. I did note along further study that south to north was the average. There was maybe a slight tilt east, but it was not that noticeable. You could get severe thunderstorm outbreaks with a slight tilt west and a slight tilt east of the Cascades. Since most of you live in the west of the Cascades, I'm going to be doing a focus on that with the 9 quote-unquote big events overall. First up, April 5th, 1972. This was a bit of a unique one because this is before I have data for number of warnings. We did have 4 tornadoes that day, including the F3 that hit Portland and Vancouver. Second F3, it also hit in eastern Washington. This was a very unique case that, frankly, I could take an entire PNW Weather 101 episode to go over it. But it doesn't follow most of the general rules, with the exception of you do have that big ridge and you do have a big system to the northwest to bring a little bit of instability. There's a lot more that went into that than just those 2 ingredients, though. May 4th, 2017, a ridge that just moved off to the east with a low pressure system situated further to the west. It was stronger than our typical upper level lows, but it was further offshore. So kind of balance out in that case. In May 24th, 2008, upper level low to the east south of the ridge was much further east. So a little bit of a unique case there. In terms of where the warnings went off, May 4th, 2017, most of them went from south to north, with a slight tilt to the east if you are south of the Three Sisters before tilting west until you got up to about Mount St. Helens, then it went east. Kind of very parallel to the Cascade crest overall. East of the Cascades, there were a few isolated warnings that went to the east. May 24, 2008, all 9 warnings that occurred on that day were in the Portland metro area proper, though interestingly, there was only 1 report of severe wind. I suspect some of this is because most of this happened over primarily rural areas, but that could be a further study. Most of this was also from south to north as well. June 4, 2009, a upper level low pressure system was situated to the southwest as a ridge moved off to the east, bringing severe thunderstorms to the Willamette Valley. June 29, 2008, upper level low was situated a little bit further to the west, but the ridge was stronger and closer to Oregon, which probably helped fuel some of that moisture coming up from the Pacific. And July 8, 2012 was another exception into the rule. The ridge was pretty strong, but no upper level low to speak of, at least at face value. Though sometimes, since this is a Euro model reanalysis, models have a hard time in showing these upper level low pressure systems, especially if they are on the smaller side. So with how far some of these lines are spaced out, I can't rule out that there was a weak upper level low that brought in some severe thunderstorms. Also, as a side note, this had about 16 reports for hail and severe wind, but there was only 4 warnings overall. Generally speaking, the Storm Prediction Center triggers a severe thunderstorm watch if they expect 6 warnings or 6 ports. The map of the warnings of the 2 that had a good chunk of warnings, June 4, 2009, most of the warnings went from southeast to northwest. That also includes a tornado warning. There was a tornado that occurred then. It did not occur in this tornado warning. It actually occurred closer to Corvallis. June 29, 2008 was primarily a Cascades East event with the exception of 1 cell that tried to get to Eugene. Everything had a slight westerly tilt except for 1 rogue cell that wanted to do its own thing that went over the Tri-Cities. Now for the last batch, and this is the late summer / fall big events, the 2 quote-unquote traditional events, August 10, 2013 and August 17, 2024, have that classic setup with the upper level low pressure system to the southwest and a ridge that just moved off to the east. On October 14, 2016, it's a little bit of a different case because there was a bigger system that was parked to the northwest in terms of the upper atmosphere. There was 2 surface systems, one already moved through, and a second was rapidly approaching. In fact, it was an ex-typhoon that some early forecasts were calling it to be a significant windstorm. Thankfully, those did not pan out. So, a very different case with that. And the 10th anniversary of this is coming up this October. I'm most likely going to have some sort of special out for that. In terms of where these warnings went, just like the other ones, primarily south to north with a slight tilt west or east. The exception, October 14, 2016. 10 tornado warnings occurred on this day, 3 severe thunderstorm warnings, and I'm not showing the marine warnings here because it would get too cluttered. It's already pretty cluttered as it is. 15 marine warnings. One thing that's pretty consistent when you look at the severe thunderstorm maps is they rarely overlap each other. And generally, when they do, you only get one more storm that overlaps. And that's because when a thunderstorm moves over land, it generally only has enough energy in the Pacific Northwest for one, maybe two cells if you're lucky. Compare that to over water, where it takes a lot more to cool the water off or warm the water or up in the reverse case, and you can get 3 to 5 cells. Like some of these locations saw 3 tornado and severe thunderstorm warnings happen within about a 2 hour time span. Very significant. And also, this was very compact, occurring pretty much from the Grays Harbor County line to the Tillamook County line. Also, one thing I will note is that warnings are only as good as your radar coverage, assuming you can see them. So these radar gaps are very important. So if you're looking at Central Oregon and the Oregon Outback, that's a radar gap. It's possible to see thunderstorms that are super tall, say above 30,000 feet. So you can see severe thunderstorm warnings if you have that, or a weather spotter or a storm chaser are actually reporting on those storms. We saw that on May 28th, 2026. But in the case of this coastal area, that's a lot harder because most of these storms that hit the Oregon coast are low top. So anywhere from about 20 to 30,000 feet versus the high top 40 to 50,000 that we see during the super big events east of the Cascades. So that means once you get south of about Newport or Walport, you are essentially blind radar wise. So if a severe storm were to hit Florence, Reedsport, Coos Bay, it's going to be a lot harder to warn that if there's no ground spotters actively looking at the coast, which is why weather spotters and storm chasers are important. Speaking for myself and for others, if you are a storm chaser, please don't do anything stupid on the road. All right, so general summary, most warnings go from south to north. If you're west of the Cascades, generally there wasn't an easterly tilt until you hit the Cascade, a crest for the quote-unquote peak season. East of the Cascades, this can tilt in either direction up to 45 degrees. Most outbreaks do come after some sort of warm or hot time period, or a big system in the case of October 14, 2016. Strong peak from May through August east of the Cascades. But west of the Cascades, you do have a tornado season that peaks in the fall months, which extends the season as a result from May to October, especially in Portland. Similar density from essentially anywhere east of the Willamette until you hit East Idaho, which is the severe thunderstorm capital of the Pacific Northwest, and that still pales in comparison to east of the Rockies. All right, thank you all for watching. Hope you learned something from this. And until next time, stay safe out there and take care.